So we are solving this equation, right? So, and here I have, so I don't have a homogeneous situation that this is not equal to 0, right?
Yeah.
Okay, so we will first solve the homogeneous equation, right? So I can go ahead and take form an equation like this, right? And its solutions will be, see, -1/2. Okay.
Okay.
And I'll email you a copy of this, so don't have to write it. Okay? So -1/2, right? Plus minus what is square root of 7/2i, right? And now great. So the solution for this part is y equals, how did we write it? E to the how much? You remember it better. E to the power -1/2 t, right?
Yes.
Okay, good, very good. 1/2 t, and then we got what?
Cosine.
Yeah, C1.
C1.
Very good. Yeah, that's our arbitrary constant that we have to. Let's write alpha, because otherwise later when we are doing the particular. So here, alpha cosine of square root of 7 over 2, right, times t. I can write it this better. I think this will be better, like syntax wise, right? Okay, very nice. And then we got what? Beta times sine of the same thing. Let me just copy and paste it here, right? Okay, good. Now, before I go ahead, we have to find our particular solution for this, right? Okay, so this function is of the form cosine of 2t, so we can, and 2 is not equal to this coefficient, right? So we can go ahead and assume what? That a particular integral, is of the form, say,
that second one that you said, e to the negative alpha.
We don't have e to the negative alpha in there. See this here?
Just wait, didn't you say because there were two right there? There's 2t.
So this 2 has to be different from this quantity here.
Okay.
If it was not, then you will take t to the -1/2 as a coefficient, right? But here is simply,
because they're different.
Exactly, since they're different, right?
Okay.
Okay, very good, very nice. Okay, so we got alpha times that, and then
so it's just going to be C1 cosine beta plus C2 sine beta.
Right. So C1 cosine 2t, right? So keep on messing up on that. C1 cosine 2t, right? And now we have to determine who C1 and C2 are, and we can, the rationale for assuming it like this is this.
You can plug it in.
No, plugging in will be later, because,
that's the last
we don't have enough. We have alpha, beta, C1, C2. But what we are doing is, for the particular integral, we are using this form to try.
You can put it back into here.
Right, very good. And see, the thing is, cosine of, cosine beta t and sine beta t, you go on differentiating them, they'll just keep on coming up. Yeah, right, exactly. So this is a reasonable thing to assume, right? Okay, very nice. I will do that very quickly. All right, so come on, derivative. Okay, so that will become negative. I'm using the chain rule, right? So sine, and then here 2, and that guy is what? Cosine, right? And then I'll take the second derivative. Okay, right, so here, so the second derivative is negative sign stays now, right?
Yeah,
so we
because the 1/2 and the 2 cancel out.
Right, and then I have 2 times 2. Don't forget that will be 4.
Oh, okay.
No, no, I'm saying negative sign is stayed because the derivative of sine is cosine, right? And I have this 2 when I differentiate because of chain rule, we'll get another factor.
Oh, that, okay.
Got it? And then cosine differentiated is going to produce a negative sign here, right? And then I got 4 here, and then what I got? Sine, right? And now, as you said, we'll take them back in here. Okay, all right. So what we
So this goes into,
right, very good. This goes into there, right? Very nice. And then
this part.
this whole part goes into there. Right, go there, please. Okay, let me just decrease the font size so that these guys can fit, right? And then the original goes in where? Right in here, right? Good. Now cosine 2t and sine 2t, they are linearly independent. Okay. So what we will do is first let's go ahead and find out the coefficients of cosine 2t and sine 2t, and the coefficient of cosine 2t will have to be 1, right? And that of sine 2t will have to be 0 because there is no sine 2t here, right? I'm talking too much. Let me first write the coefficients, okay?
Yeah.
Okay, good. So negative 4 c1, right?
Okay.
And then who is the next guy? No, I'm collecting only cosine 2t at the moment.
Oh.
So that will be 2 plus 2 c2 from here. Right now I'm collecting only the coefficients of
all the cosine 2t's. Oh, I see what you're doing. Okay, so cosine, so there's a 2c here.
Right, so it's
right,
2c2,
okay.
right?
And also 2c1.
Beautiful. Thank you so much.
Okay.
That gets to be 2c1. Okay. Now let's just quickly fix something here. That is,
it's just going to be negative 2c1.
Very good. That's what it will be. So let's postpone it to the next part.
Oh,
now,
okay.
Just give me one moment because I want to make sure that we did well, it was all positive. So this is negative. Good. We are good. I hope we are good. Okay. All right. Otherwise, we'll fix it if we are, if we made a mistake, then we'll have to spend time fixing it. Right?
For all the signs, yeah. So this is going to be one.
Beautiful.
This is going to be another one.
Okay. C1, very nice, and then
that one right in there. And because this is a positive,
right, C2, right?
And the 2, yeah, the 2 in front of it.
We have a 2. See, I'm not paying attention, right? Let me just minimize the email thing. This thing comes up and I get distracted. All right, good. Okay, so do you have all the 2's accounted for and everything? Right. Thank you so much. Okay. All right. 2 t, right? And that equals what? Cosine 2t. And I'm going to do exactly what you asked me to do. That is here. It will be negative 2c1, right? And then it is negative 2c1 plus that, right? And then what we got? Negative 2c1 and negative 2c2, right? Makes sense? Good. So if we compare the two sides, what do we get? We get the following, right? That we got this equals how much? 1, right? Won't it be 1? Because on the right hand side, I have 1 times cosine 2t plus 0 times sine of 2t. The way you solve remember for the partial fractions is similar kind of thing, right? See, so see here, I have this constant times cosine t plus this constant times sine 2t, right? And on the right hand side I have 1 times cosine 2t, and there was no sine 2t, so that means it's multiplied by what? 0, if we want to compare, right? So this coefficient has to match with this. Okay. All right. And then
that has to equal to 0.
Beautiful, very nice. And so then that, what does that tell me? That tells, first of all, this one will give me right away that C2 is negative C1, isn't it, right? Negative C1, right? Are we good? And when C2 is negative C1 or C1 is negative C2, all right. Okay, so C2 is negative C1, right? So we can write this here, right? Negative C1. Okay, and then that becomes what? Negative 4. C1 equals 1, which means our C1 will be 1. Very nice. So C1 is negative 1, 4. Okay, and who my C2 will be then? C2 will be just
positive 1.
Beautiful. It will be positive 1/4, right? C2 will be positive 1/4, right? So this is a particular solution, right? Okay, that is, who is a particular solution? Y sub. I'm just stressing it for particular solution. That's going to be what? Negative. Yes.
Yeah. Oh, the C1. So yeah, negative 1/4 cosine 2t.
Cosine of 2t, right?
Plus
positive
1/4.
Very good. Positive
sine 2t.
Sine 2t. Very nice. Okay. So now what happens is this: if we bring our original equation back, then remember this. See this here? This is a solution, right? I mean, notice this, okay? That this is a particular solution, right? And what happens is, if we add this quantity, this one here, okay, to this, that also is a solution, because when you substitute this, then this whole portion will come out to be what? 0, right? So 0 plus this guy will be a solution as well, right? So my general solution will be who? The general.
So the first 0 solution plus the y.
Yeah, right. Okay. So for the, where is it? We got this, right? Okay. And oops, not that. Sorry about that. Where did it go? Here. Okay, so we got that, right? And then I will not put a plus sign, because then I could have put a plus sign, but that. Is that good?
Yes.
Okay. Very good. So this is, just a moment. Oh no, I did not copy it. Well, I apologize. Just a second. So this becomes now a general solution. Oh yeah, right. That is still. Thank you so much. Okay. So now remember this. We have the two initial conditions. Okay. So let's go ahead and work with those two conditions, right? Okay. So I can erase it now, right? Okay, 60. Okay. So it would not be too much of a pain to take a derivative here, right? Okay, let's take derivative. Oh, it will be like quite a bit, but yeah, let's take it anyways. Okay, it doesn't hurt, right?
So the negative 1/2 goes
negative 1/2, right? Okay, and then what happens? Then I have plus. I'm applying product rule on this.
Yeah, because first this, then this.
Right.
So the derivative of this plus the regular of this,
right,
plus the derivative of this times.
Very nice of you. Thank you so much. So we get negative alpha, right? Negative alpha times the square root of 7 over 2, right? Square root of 7. Yeah. No, but t, where is it? T won't come in because we are using simply the chain rule here, right? So we will have, so what the derivative of cosine beta t is? Negative beta times cosine beta t. Oh, right? Yeah, I know there is too much here, and we are not used to dealing with this much anymore. But that's okay. We were doing it good, right? Okay, makes sense. Okay, and then what happens next? Let me reduce the font size further because okay, and then we have what after that? Plus beta times, right? Oops, not this. You know, we're just, right, exactly. We are just doing just what you call that, a routine calculation, right? Very good. But anyway, good. So where do we put that in? Here, right? Great. Okay. So very carefully, let's see here that what y sub 0 will be. Look at the.
Oh, but we didn't do this part.
And we don't have. See, the thing is, we just. Oh, I see. Yeah, we did not do the derivative. You know what I did? I have no idea why I keep on doing these kinds of things. I just wrote it as it is, right? I don't know why I did that. Oh yeah, right, because I did not take the derivative, right? Good. Thank you. You were so alert, okay? So this plus 1 over 2, right? Then sine of what? 2t, beautiful. Okay, and then
1/2 cosine.
1/2, very nice. Thanks for your alertness, otherwise it will be so frustrating to trying to find the mistakes. And today both the times you were right, I was wrong, right? So here, so when I don't go y sub 0, this is 1, and then this guy will be alpha, right? And here this will be 0 when
and alpha of 1, so that would be 1.
That,
oh yeah, alpha.
So just
okay,
simply alpha. Oh yeah, right. You were right.
And then this is just 0. Okay, so
it's negative. Then oh, it's behaving very well, isn't it? Right? Okay, 1/4, and that's it.
Yeah, because everything else goes
good.
to 0.
Oh, very nice. All right.
And that all equals 0.
Then okay, right. I'm just trying to simplify it for a second. Yeah. So and this equals 1 actually. It says, right?
Oh, 1. Okay.
Y0. So this equals 1. So alpha will be 5/4, right? Okay. So that gives me alpha as 5/4, right? Very nice. Okay. Now let's write the y prime 0, and I'm just depending on you because I somehow, yeah, somehow I keep messing up here. So this is negative what? 1/2, right?
Yeah, 1/2
then
to the 1. Okay, so we're good.
We agree.
Times that whole quantity.
So that
to
times
the alpha.
Right. So we simply get alpha here because this will be 0, right? This will be 0 and this will be 1, right? Okay. Then plus I get a 1 because of this, right? This will disappear. Okay. And here, see, I forgot writing that guy here. I should have written it, right? Seriously? Before that, because when I was different, right? I forgot that, and we both missed it. So I can say it's a common blame, right? Okay. So we go there.
Yeah, we get
that, right? And then what we get? This will be 0. 1/2 plus 1/2, right? Good, very good.
And all that's going to equal -1.
All that is going to equal -1, right? So all that equals -1. So when I move it, that all that equals negative 3 over 2, right? Or let's multiply with 2, I like it that way. Let's multiply the whole thing with a 2, because that will make things look a little friendlier, right? Oh, they were nice too. Fractions are good, but okay, plus 1. Okay.
Minus equals negative 2.
Equals negative 2. Very nice. And alpha is 5/4, right? And I'm going to go very leisurely now, okay? Because even if we made a mistake, still we got a hang of the procedure, I hope, right?
Yes, definitely.
Okay. All right. So what we got now, this is 5/4, right? Okay. Then we have a plus sign here, right? And I could transfer, and both of us can add fractions pretty well, but it'll be a good idea. Let's multiply with 4. Okay. All right. So we have this, right? And we got 4 here
and 8
and negative 8 there, right? Good. Very nice. So when we move, so this is negative 1, negative 5 plus 4, right? When it moves over there, will become positive 1. So I think that will simply become negative 7. Am I right or wrong? Right? Okay, so what we just made up a problem quickly from just like that, and it doesn't turn out to be too bad.
Horrible, yeah.
No, but the thing is this. Look here, this is
it's not bad, yeah.
Yeah, it's not right. Exactly.
It's not like
yeah, I know. Some of the books questions are like go all over, but that's okay. So here this will be what is square root of 7/4, right? Makes sense. So finally, our solution will be what?
Just plug in the alpha.
Right, plug in these guys. Okay, so we got 5/4, right? Now, and then here we got negative what? Square 7/4, right? Let's check the solution in two different ways, okay? One is this, that, let me, or we should just check it. Let me see if it would tell us that way. 2, 3, right? Now, what was my equation? My equation is, let's just write it down, d2y, or we can write the same way. We'll just say independent variable is t, right? Where's the equation? I think I remember the equation by now, but anyways, here we go. Right, so we got that, right? I mean, we can substitute and check, right? I'm just checking it like this. So how much was our y0? That was a 1, I think, right?
1, yes.
Okay, that was a 1. And how much was my y prime?
Negative 1.
That was negative 1. Okay. And of course, sometimes we may be given values at y and all that, right? So, please, where is it? Exact. Okay, so how did we do? Looks look all right, right? I mean, see, this part is good. See this here? These guys are this, and here we got well, they took it, they sent it downstairs, which is all right. Plus, you know what we did? You're so good, thanks. I mean, you were watching it carefully because I always make some algebraic mistake somewhere. So we did good, right? Okay.